now. It's a great pleasure for me to chair this session on climate modeling and high-performance computing. Climate change really is happening. There is now overwhelming scientific evidence now that climate change is indeed occurring. What's happening and that is new now is that the politicians and governments get involved as well. And those politicians and governments ask new questions. They're not only interested in essentially the global warming, the degree of global warming around the whole globe, so the average. They're not only interested in issues like how to reduce global emissions. They're particularly interested in how it affects their backyard, i.e. how will global warming affect, what are the effects on the regional scale. And to do climate modeling and produce reliable statistics on a regional scale, one needs a new generation of climate models. And this new generation of climate models will have to run at a much higher resolution and will have to have many new processes included. And it's quite obvious this next generation at higher resolution with more processes will have a much higher demand on high performance computing resources. However, this is really the question now. The catchphrase now in the climate modeling area is mitigation and adaptation strategies. And we have 3 speakers now in this session which will talk to us and tell us about the path to this next generation of climate models. So the first speaker is Professor Dr. Wolfgang Hiller. He is the director of the Computing Center at the Alfred Wegener Institute for Polar and Marine Research. He as well holds a full professorship for scientific computing at the University of Bremen. And in addition, he has coordinated the German Climate Grid project. Please.
Okay. So thanks a lot and good afternoon, ladies and gentlemen, for this opportunity to talk here. You see that the title of my talk, The Grid as One Enabling Technology for Advanced Computing and Climate Research, and the one is written in capital. In capital because I was coordinating for the last 3 years one of the first German e-grid projects funded by the German Institute of Research, the Collaborative Climate Community Data and Processing Grid. Center around some basic things. First, the motivation. Petaflops high performance computing from the user perspective, because normally when we assemble here, the user perspective sometimes gets a little bit lost. I think it might be nice to talk a few words about that. The grid is enabling technology for high performance and advanced computing and climate research. Well, I think it's worthwhile mentioning because the grid seems in some minds already like the technology of the past. I think grid still has a future and one can do a lot of useful things by grid technology. User perspective, of course, what the user will do is mostly cope with the enormous amount of data. And so some trivial tasks like data selection, access and control, and workflow with PB, so this means petabyte data sets, is in the next few years, I think, a challenge, and users have to cope with that. And I will give you then some insight in this German climate grid, data and processing grid, the technical realization, workflow, scheduling, security, middleware. And I give you some workflow examples, and last but not least, look into the challenge of the next IPCC assessment report 5, which will be mainly based on grid technology and in the German part of the collaboration. You see, I just a few words to the motivation. Petaflops high performance computing gradually transforms into advanced computing scenario. What do we mean with advanced computing? We see a lot of new challenges are going on, and just to mention a few, multi-core scalable algorithms, new numerical techniques, unstructured grids, new data structures, hybrid programming paradigms, transparent use of accelerating techniques, and so on, SIMD cell, GPU stream computing, or streaming SIMD extensions, only to mention some of the new features there. And I think that's a lot of stress for the normal user already. you must imagine that still in climate science, the normal user knows what 4090 is and what MPI and OpenMP as programming paradigms mean, and he's still coding. The user has to cope with the new challenges, and he has also to face that he will have an enormous data production rate. So this increases, of course, the complexity of data access, because one very basic thing is that petabyte data sets remain at their location where they were produced. I don't think it's feasible to move them around. And so the whole process of data selection and comparing different data sources is quite non-trivial task, because this means authentication and authorization and problems at different HPC sites have to be addressed. And last but not least, everything which means international collaboration. So something like cross-domain validity of certificates and international interoperability is still in the future, and nobody really knows how this will happen. We only know that we will have to solve these problems in the next few years. Background and also end of the motivation phase here in my talk is the example for new HPC resources in northern Germany. I mentioned the figure now, which will be fully established in next year, a new IBM system at the German Climate Computing Center, 140 teraflop peak, nearly 8,000 cores, 20 terabyte memory, 2 petabyte disk space, and the HLRM, and fully established will be then a new SGI Intel-based system at 2 sites, SUSE Institute Berlin and Computing Center Hannover, with 300 teraflops roughly peak and almost 25,000 cores, 92 terabyte memory and 1.84 terabyte disk space. So in these computing systems, a lot of data will be generated, especially if you look at this factor here. For the German Climate Research Center, this means a factor of 60 increase in sustained throughput. And now, if I continue, you see that all the dreams which the individual researcher has, they can become true. He can put more subsystems in his coupled climate model, refine each of the subsystem model in temporal or spatial distribution, and then try to compute this on the new HPC resources. I don't want to explain this picture, only show you that nowadays the prediction of climate change involves a lot of simulation tasks, and that each of these boxes is a non-trivial, fully blown dynamical model. One picture to show you the development of the archive capacity at German Climate Computing Center. This is still done, the figure was done, you see the end number there is 2006, with the old vector HPC system. And there we already have something like 4.5 petabyte in the archive. Model experiments in the future with the new HPC resources I showed you, they will largely have the focus to have longer integration times, higher spatial resolution, more temporal resolution, and more computations with multi-model, multi-ensemble runs for climate projections. Last but not least, I mentioned the next assessment report for the IPCC. So there is the experience from the last assessment report.